Well, happy Friday, my algebros. As promised, I wanted to record this video after I went through the study guide with you to make sure I covered the things that we talked about in class. Happy Friday for my B-Day students and happy Thursday for my A-Day students. All right, on the first one, we see that we are substituting the value of x and y into these equations to see if they were solutions. So if the values substituted in are true, then yes, it is that point on that line. If when you substitute it in, it is false, like 8 equals 6, this is not true. Therefore, it's not a solution. It's not a solution. And if it's not a solution for both of them, then it's not a solution. Right? Because we're looking for a system that has a solution, and a system means it has to work for both. Okay, let's look at this next one. We're going to substitute in our x and y values here. And we see with the first equation, it works because 0 does equal 0. And we substitute it in for our second equation, when x is 1 and y is -2. And we do the math and we see -7 equals -7. So it's both are true. So yes, it is a solution. On number 3, we're solving by graphing. So first I use my y equals mx plus b. I start with my -5 as my y-intercept, and my slope is 3 over 1. And I rise 3, run 1, and I put all the slopes in and draw my line. Because with graphing to solve, sometimes if you're not exactly perfect on your lines, you'll miss the solution. On the second equation, I'm doing that in red. I start with my y-intercept of -3, and my slope is 1. And I draw that, and I see the one shared solution is 1, -2. On number 4, I graph my equations again. This is a negative slope down 2 and over 1. I could also apply the negative to the 1 instead and go up a +2 and over a -1. Then I draw my second line in purple, and my y-intercept is -2, and my slope is just 1 again. So I can see the shared solution here is 1, -1. So remember that point where they collide, that's the one solution. So then we look at solving by any method we want. Substitution, elimination. As you guys know, my favorite is elimination, but on number 5, it is set up to solve by substitution. So I substitute the y value into the second equation, and this gives me the freedom to solve for x because there's only one variable. And after this is just chapter 1, combining like terms and isolating the variable. So we're doing PEMDAS to evaluate the expression and SADMEP to solve. And we get the x is 5. Then you substitute it back in for the y equals equation to solve for y. Now we know x is 5, 5 minus 7 is -2, and we have that one solution. On number 6, it is set up to solve by elimination because it's ax plus by equals c, and we also see that the y values are the same but opposites. So when you add up the two equations, we eliminate the y's and we solve for the x's. The reason why you eliminate is because if you have 3y and you take away 3y, you don't have any. You have 0, right? It's not like dividing. You can't divide to get something to become 0. Then we substitute it into either of these equations. I just happen to choose the top equation using 2 for x and then solving for y. And we have our one shared solution here. On number 7, I need to change one of these equations in order to eliminate them. When I look at the values here, the common multiple of -5 would just be 5, and the common multiple of 7 and 3 would be 21. So obviously 5 is smaller, so I'm just going to multiply one of these equations by -1. I chose to do the top equation, And I went ahead and just distribute that -1 and applied it underneath. Now I add up my two equations, and I've eliminated the x's, and I solve for the y. I get -2. Then I can pick any of the equations. I happen to choose the second one for this to solve for the x, because now I know the y is -2. And I get -5. So you can see, if you're really good in chapter 1 and 2, these are not very hard. But if you still struggle with solving for a variable, it gets really tricky pretty fast. Number 8. Again, I'm looking at what I want to eliminate. This, our common multiple, would be 6, and this would be 4. Remember, they have to be opposites in order to have one positive, one negative, to add them up to eliminate. So I need to multiply that -4 to the bottom equation so that it will eliminate the y's. So I go ahead and do that. I just rewrote the equation on top so that I can distribute the -4 to the top equation, add them up, right? Don't forget that we're always adding these up, and I eliminate the y's and solve for the x's. Get -4, and again I substitute back in to solve for the y's. And so this point is going to be -4, 0. So now we've learned the skills of how to solve using graphing, substitution, and elimination, and we use them in real world situations, right? Like Maribel and her coins in her pocket. On these, it says on here too, the hint down here, we really want to make sure we're paying attention to our hints. Use one equation on the number of items and one on the value. I like to do the value first because it tends to be what people struggle with the most. So value is money. And it says that Maribel has $1.25. So it tells us the total value that she has. And we know the value of a quarter is 25 cents and the value of a dime is 10 cents. The other part of the hint is to do one on the total amount, right? How many, or quantity. And that's, how many coins does she have? She has 8. What is it made up of? Quarters and dimes. Now that you've set up your two equations, you can solve using elimination or substitution. I'm personally going to use elimination. So I look at what I want to eliminate, and I choose the smallest number, which is 0.10. I have to have an opposite value, so I multiplied the bottom equation by a -0.10. And the top equation I keep the same. I add them up, and I isolate the variable. I find out that I have 3/4, and then I can substitute back in. If I have 3/4, that must mean I have 5 dimes. And that makes sense because 3/4 is 75 cents, and 5 dimes is 50 cents, and 50 cents and 75 cents, right? 50 cents and 75 cents is $1.25. So we know we're doing it right. All right, number 10 is these rate problems. All rate problems, it says on the hint, I make a table with 3 sections. We're going to make this section when we do these so that it's in standard form. So I do my rate times my time equals my distance. In my rate, I always have the help of the current or against the current. So we always represent the X value is the person or the plane or the bird or the boat, whatever it is that has the help of the current or goes against the current. And the time with the help of the current will always go faster. So I know it takes 2 hours with the help of the current and 3 hours against the current. And the distance is the same because Paula is rowing somewhere 6 miles and rowing back, right? Now in chapter 1, we learned that every time we have a multiplication of a family like this, this rate here happens to have two variables, we use the distributive property. So we go ahead and distribute, right? We distribute the 2 to the x and the y. And again, down below, we distribute the 3 to the x and the y. Now you have your two equations and you can solve using elimination. The fun thing about all of these rate problems is you always eliminate the y value because it's already opposites. One's positive, one's negative. And the common multiple is the same on x and y. So we're going to get it to be 6, so we multiply the top by 3, the bottom by 2. We eliminate the current first so that we can solve for the person, the bird, the plane, whatever, the boat. And we can see Paula Rose at 2.5 miles per hour on her own without any current. And then we could solve for the current, substituting back in the x value to solve for the y. And we find that the current in this case is 0.5 miles per hour, which makes sense. Because if you take Paula and if you give her the help of 0.5 miles per hour, her speed would increase so that her speed would become, if you add 0.5 miles per hour, her speed, her speed would change to be 3 miles per hour, which means it would only take her 2 hours to row that 6. That makes sense, right? And then if she's going against the current, that means her rate would go down by 0.5 miles per hour. So she could only row 2 miles per hour, which makes sense that it takes her 3 hours to row 6 miles. All right. So we know Paula's 2.5 and the water's 0.5. On the next question, we have another version of our mixture problems. I'm just going to clean this up so it doesn't distract us from what we're talking about now. On our mixture problems, we write one about value, right? So we're going to start there. Value, we know the values of peanuts and the values of the raisins for the total value. Now we have to think about this. The total value is the quantity times the selling price, right? This new mixture is 8 pounds, but what are we selling it for? We're selling it for $2.20 a pound. So actually, our total value is $17.60. Then we write another about the quantity, and the quantity is peanuts and raisins for a total of 8 pounds. And now you just can go ahead and solve using elimination. Again, I like to eliminate the smallest thing, so that would be the peanuts. And I use the opposite value to distribute to everything in the equation. And I isolate the raisins, and I find that we're going to have a very raisin-heavy 6 pounds, which means that the peanuts have to be 2 pounds. And at the end of this video, I'll show you the notes we took about how to write a note card to help you out with all these formulas, right? All right, number 12 is a perimeter problem. Perimeter problems, we always sketch these out. We draw this rectangle to remind us that we have 2 widths and 2 lengths, which gives us our perimeter equation of 2 widths plus 2 lengths. And they have to tell you how big it is, which is 56. They also tell you what the length is. Sometimes they'll tell you the width. This time they've told you the length. And now we solve by substitution. We substitute in what we know to solve for what we don't know, which is the width. And once we know the width, using our Chapter 1 skills, we can substitute that back in and solve for the length. All right, moving on. On the next question, we have Alex and Jeremy are both saving money. We can write the equation for Alex. What he has is $30, and he's going to save $5 a week. And then we can see Jeremy has $48, but he's only saving $4 a week. And the question is, when will they have the same amount of money? We learned in Chapter 4 that all these equations are always y equals, because that's the function. And we learned in Chapter 5 that because it says y equals 1 and y equals the other, we can substitute the value of y in for another. So we could set these equations to equal each other because y equals y, right? And in our lessons, we talked about money and how a $20 bill can be 2 tens, or a $20 bill could be 4 fives, or a $20 bill could be $21 bills. And you can exchange them because they have the same value. So y might look different than a different y, but because it says they're equal, we can exchange one for another. Like I can give you a $20 bill or 2 tens or 4 fives or some combination of those. All right. So we now just get to isolate our variable, and we see in 18 weeks that both equations will have $120. So in 18 weeks, they will have the same, and that same amount is $120. All right, we are in 14 and 15 talking about whether something is no solution, infinite many. We've been doing one solution, so no solution would mean they'd have to be parallel lines, right? Parallel lines have no solution, they never touch. Where infinite many is the same line, so they have all the same solutions. But we can use systems of equations here. If I get a common multiple, I'm just multiplying by 2 because 6 and 12 can become the same value. And I see with this that both x and y's eliminate when I go to add them up. But 10 plus 10 is 20. 0 does not equal 20, so I know that these are no solution. And a little side note that we did in class, I went ahead and solved for the slope on these, and you could see that the slope is the same. It's 6/7, right? And for the other one, it's also the same, right? So we found that the slope is the same because they're parallel lines. Okay. On 15, this is set up for substitution. So I substitute in, and when I combine my like terms, it eliminates the x. So I get 4 equals 4, which is true. So I know it's infinite many solutions. But if I go one step further and solve, I see that they are the same equation. So of course they have the same. All right. 16. In class, we did this all 3 ways. So first I write the equations for bowling squares. I see my equation is y equals 2.5x plus 1 because the initial fee to rent a shoe is going to be 1. And then 2.5, if I want to solve by graphing, I need to switch to a fraction. So 2.5, $2.50 is 2.5, which then becomes 5/2 is our fraction or our slope. And I graph that line. And then for Bahama Lanes, it's $7 to rent shoes and only $1 per game, which shows us when we graph these that they collide at exactly 4 games, and that cost is $11. This is how you solve this question if you want to do graphing. And you only have to solve one way for credit. But if you choose to solve this all 3 ways like we did in class, you can have extra credit. So if you use substitution, like we did next, because y equals y, we found the same answer, and we did elimination, moving the equations to standard form, and multiplying one of them by -1 to eliminate the y's, we also got the same solution of 4 games, $11. The last 3 questions on this test are going to be review. 17 is solving for a variable, reminding ourselves how to do PEMDAS before we do SADMAP. And 18 was solving for y to get the slope-intercept form. And then 19, reminding us how to use the point-slope form if I have a point and a slope to solve for y and get our y equals mx plus b. All right, lastly, I want to go through some pictures we had on the board of how to write a note card. So on this note card, you could see when we did these in class, we first tackled the mixture problems, and we always have 2 equations, right? One on value, one on quantity, and if it's a coin problem, they give us our total value. But it's a mixture to sell, we have to calculate it, and we calculate it using the quantity times the new sale price. We also talked about perimeter problems, that you could have all of this on a note card, by the way, because it's not giving you specific problems, but it does give you hints. You write your equation that never changes, and then they have to provide the perimeter, and then they have to either provide an equation for the length or the width, and then you solve by substituting. Okay, the next part was our rate problems. We wrote this on the board, and we talked about how, because the rate is always in parentheses here, that we have the help of the current, and then we're going against the current, right? That X is always the noun, Y is always the current, and we distribute the time to all of these to write our equations, and then we always eliminate the Y values. All right, you guys, make sure you have your note card done. When you walk in, you'll be turning in your study guide, because we did it in class. So don't forget it. Have your note card, and it's going to be a great day. Talk to you later. Bye.